Hey everyone. So today we're going to take a look at how to do soft IK with control rig. Soft IK is a way to avoid this kind of snapping motion that happens when you pull your effector on an IK chain. So this first chain here has no soft IK and no stretch. The second one has soft IK but still no stretch. This one has stretch but no softness. And the last one has stretch and softness. Okay, so let's take a look at what's in there. Quickly, I created this scene with just creating 4 chains and all my controls. And then I have my 4 different solvers here for each of the chains. The one we're going to take a look at is this function, which is controlling the soft IK. So as you can see, I'm changing the position of the effector with my soft IK function. So let's turn the debug mode so that you can see something and understand how it works. Let me reduce this for the example. So what's going on here is when my effector is being pulled to a distance greater than this green circle, it's going to start to lag behind. So you see how as I'm pulling, my effector is actually left behind. And I have to pull more for it to catch up with the red line, which is my maximum distance, which is the length of the chain. So if I turn that to 0, removing all the softness, you can see that there's no compensation at all for me pulling the effector. So what we're trying to achieve here is by giving it some threshold, some blending motion here, we kind of prevent the effector to move too quickly to the red line. Okay, so let's take a look how it's done. I'm not going to recreate the function from scratch this time. There's a lot of nodes, but hopefully you can follow along and it's not that difficult, I promise. So the first thing I need is the initial length of my chain, which is going to be represented with this red line over here. The way I do it is simply I take the distance between bone A and bone B and bone C at the initial position, and then I'll add them together, and that's my chain initial length. Here I want to get the position of the effector relative to the bone, so I just subtract the position of the effector from the position of the root bone. And I also is going to store this length because it's going to be my current length. So this length here is the distance between the root and the current control, the current effector control. Finally, here I compute the softness start distance, so the green light. The way I do it is I have 2 parameters. One for the softness distance, which is a percentage of the chain distance. So here I said 90% of the chain's distance. So if I reduce this to 0.5, you see now it's 50% of the chain distance. And then I have a 0 to 1 coefficient to reduce this amount. So usually this is what the rigger is going to set. Is going to try to find a good value here that works nicely. And then you can expose this parameter to animation so that they only have to worry about a 0 to 1 value. So for example, in that case, I usually make it fairly small because I want that to be subtle. So maybe 0.95 is what I like. And then if animation wants to turn it off, they can just set that to 0. If they want only 50% of what I've proposed, they can also do that. If they want, if they want the whole effect, or even they can go beyond, if they can put 2 and get even more. So this is much easier for animations to manipulate, and this is more like a rigor setting that they can prepare ahead of time. Okay, here I'm just doing some debug drawing. This is to draw the green line, and this is to draw the red line. And then I have a print over here that's going to help me show you some values as I go along. All right, so what needs to happen? Well, the first thing I want to do is I want to get the ratio between this green line and the red line. So when I'm on the green line, I want this to be 0, and when I'm on the red line, I want that to be 1. So the way to do that is I just get the current distance, subtract the green line, so the start distance, and then I do the same for the red line. So I get the maximum distance possible, and I subtract the green line, sorry, and then I divide one with the other. So if you take a look over here, when I'm on the green line, I try to get as close as possible. You see it's near 0, and when I'm on the red line, I am near 1. Okay? So that's the first part of it. Then I'm going to use an exponential. So if you're not familiar with what an exponential is, this is this function where if I pass 0, I'm going to get 1. And if I pass 1, I'm going to get a number that grows very quickly. So the bigger the number, you see how it exponentially grows, which is really nice. But I'm actually interested in this other part of the chain, the graph, where here it reduces very quickly to 0, but never reaches 0. Okay? So in order to do that, I'm going to negate the value so that I can use this part of the chain first, of the graph, and then I'm going to run it through an exponential. So now, if I plug this here, and if you look at this number over here, I hope you can see something. When I'm on 0, I get 1, and when I'm on the green line, I get 1, and when I'm on the red line, or the more I pull, I'm gonna get. Let's try to zoom on that a little. The more I pull, the closer the number is going to get to 0. So this is to say that when I'm at 1, I want a perfect match. I want my effector to be exactly where my control is. But when I'm on beyond this, I'm going to try to make it approach the position of the chain length, but never really actually reach it. It's never going to be 0. It's going to be closer and closer to 0, but never actually at 0. So using that, I'm just going to do 1 minus this. So now when I'm on the green line, I get 0, and the more I pull, the more I get close to 1. And I'm going to use that to compute the new soft effector distance, which means we're going to get the distance between the root bone over here to the effector. So we're going to do that by taking the softness start distance, so the green line here, and then we're going to multiply this factor. We're going to multiply the distance between the green line and the red line, so this distance here. We're going to multiply it by our exponential function. So now we're going to get something that gets, as I pull away, gets closer and closer to be the max distance, but never reaches the max distance. And that's what's going on here. So now all I need to do is, I have this vector that I computed before that goes from the root to the effector position, which is the target. Remember, I computed that here. And I'm going to set the length using what I've done here. And then I'm going to take the position of my bone A, and I'm going to add this new vector with the length that I have updated from my soft distance. And I'm going to set that as my output transform. I keep the rotation and the scale from the original effector, but I update the translation to be this soft distance here. And here I just have a quick condition, because if this is less than 0, so if I'm before the green line, all I want to do is I want to use the effector position. So anything before I reach the green line is going to just simply match the effector position. And it's when I reach the green line that it's going to switch, and you can see it here toggling, that it's going to start using the softness. I also added a condition where if softness is 0, so it's turned off, then it's also just matching the effector position. And that's pretty much it. So that's the magic behind the softness. Now, there's one issue with this approach, is that it doesn't work with stretch stretch IK. So here, if I enable the stretch, you see that my chain is not stretching because my function is overriding the effector position. So even though I'm pulling the effector over here, the transform I'm passing is the one I'm drawing here, which is never going to match the position of the effector. So that doesn't work with stretchiness. So in order to make it work with stretchiness, I have to change the function a little bit. And I wanted to show you both options because there's use case for both. So this one, which is going to be this chain, works with stretchiness. And you can see how it's stretching the bone even if you pull the effector beyond the initial length. So let's turn off debug mode here and turn it on over there. So now you can see, oops, let me just reset all that. Okay, you can see that I have my stretchiness happening, my softness happening even when I stretch the chain. And it's really much the same setup. I have everything the same. The only difference is I need the lengths of bone A and bone B because I'm gonna multiply I'm gonna scale those bones as I'm stretching the chain. Actually, let's go back here, and you see here instead of returning an effector position, I'm returning the lengths A and B of the bone, which I plug directly here in the lengths A and B in the basic IK node. So here I need this initial length of bone A and B. Everything else is the same. This is the same. This is my debug, which is the same. This whole part is the same as well. And the difference comes here. I also compute the softness blend, but this time, so you guys can see, this is exactly the same over here. And now what I'm going to do is I'm just going to divide the current distance by using this value that I calculated for my softness distance. And then I'm just going to use that as a scale multiplier for my chain bone lengths, bone A and B. And that's really just it. So it's really the same approach, the same math over here. And the only difference is I use that as a factor to multiply the lengths of each bones. Same conditions here, where if the softness is 0 or if I'm before the green line, then I just use the original lengths of each bones. And that's it. Yeah, thank you.